Welcome. Good afternoon. My name is Philipp Schmitt, and today I'm going to present you how automatic, collision-free, and online motion planning can help you improve the speed, efficiency, and ease of use of your robotic systems. The challenge that we want to address here is how we can simplify robot programming in scenarios where we have low volume and high mix production. So let's say we want to manufacture a few hundred items of one product, then switch over to the next one. The robot makes the next few hundred products, and we don't want to do any programming in between whatsoever. Let's take a look at the challenges that this poses when we want to do this with today's robot programming. First, there's a lack of flexibility in today's robot programming paradigms. You need a lot of training for your staff to be able to program robots. There's a quite large integration effort between your robot system and your surrounding automation equipment. And then there's finally a lack of standards. Let's take a look at the lack of flexibility. When you want to program a robot today, essentially what you do is you move your robot through all the steps of the motions that it has to perform and record these motions to be replayed later on. Essentially what that means is you're taking your digital machine of the robot and treat it as an analog device, which means that nothing that you program here can be reused in any other application or even any other hardware setup that might resemble very much the one that you're dealing with right now. All of this needs then to be done for different robots and even robot brands, and your staff needs to be trained for different human-machine interfaces, different programming environments, and even different programming languages in which these robots operate. Then, afterwards, you need to integrate your robot with your remaining automation system, which means that you have at least 2 programming environments that you need to use, maintain, and synchronize during operation, for which standards are also lacking at the moment. The solution that we present to these challenges rests on 2 pillars. On the one hand, there's the SIMATIC Robot Library, and on the other hand, we use online automatic collision-free motion planning. The SIMATIC Robot Library is one interface for all different or many different brands of robots and takes care also of the integration effort. So instead of programming in 2 devices, your robot and your PLC, and using multiple different human-machine interfaces, you have one integrated programming interface with one way of talking to all kinds of robot brands. The automatic motion planning, on the other hand, takes care of intermediate via points that you would otherwise have to program, takes care with collision avoidance, optimizes the motions for your particular system, and also lifts programming from a low-level kind of analog type of teaching to a task-level motion programming where you tell the robot, move from a piece from here to here and figure out the rest yourself. So instead of doing this kind of analog teaching, we use digital models of our system that we want to control. There's digital models of our workpieces, the products that we want to manipulate, the tools that we use. There's digital models of the robot and the immediate environment that the robot operates in. We feed this into our motion planning software along with a high-level target description, which then computes a path with no need for intermediate via points and which optimizes the path for your particular setup on the fly as you execute the motions. This has a couple of key benefits. There's reduced programming effort, because there's also no need to program the via points. There's reduced risk of collisions, because the collision-free motion planning takes care of avoiding collisions, and there's also no need to validate the motions, because the collision-free motion planner, as it is, validates motions for you. And then finally, every single motion is optimized on the fly for the particular target that you want the robot to move to. All of this is integrated in the Siemens ecosystem, most importantly with the SIMATIC Robot Library as one generic backend to execute motions on your robot, and also with the SIMATIC programming environment and human-machine interfaces that you have there. So does this work on your robot? And the answer is most likely yes. As of now, the list of partners that is supported by the SIMATIC Robot Library is quite extensive. On this list here, you can see roughly 75% of the robotic market, which is either already supporting the SIMATIC Robot Library today or planning to release the support in the next coming months. In the lower section of this video, of the slide, you can see a couple of videos of different robots executing the same high-level task description that we gave it, move around this block, but figure out the motion on your own, optimize the motion on your own. And you can see that the SIMATIC Robot Library abstracts away the low-level interaction with your robot and acts as the backbone for our solution, whereas the motion planning gives you the opportunity to do high-level task programming and abstracts away robot kinematics and geometry. So what that means is you can take your application and run it on any robot that you like. Let's take a look at an example from practice. Not far from here, in Fürth, there's the Siemens electronics factory with this particular use case that we addressed. The Siemens factory in Fürth has the particular challenge that it manufactures products at the end of their life cycle. So these little electronics components that you can see here, they are assembled in small batches. A few hundred of one product are made, but many hundred different products have to be assembled in the same factory. So this robot cell that we designed here is to address this challenge of assembling many, many different product variants. So what you see here is we're assembling these little servo drives in this case, small electronics components with housings and PCBs, and the different products set up to be assembled share some structure. But they're still different, and for everyone you need different robot motions. Also, if you want to have a flexible assembly cell like this one, you need to take care of the logistics. Parts need to come in, parts need to move out of the robot cell, and this needs to be organized with the surrounding system. So the robots here need to deal with the fact that parts can arrive at all kinds of different in-feed locations and go away at different out-feed stations. And finally, parts need to be detected by cameras and shift in position and have different orientations. And if we were to address this with state-of-the-art motion programming techniques, we would have to teach thousands of different motions here, and not just teach them, but also validate them, that they're within the kinematic limits of the robots, that they do not collide with the environment, and this is just not feasible at all. Now imagine something changes in the setup. Let's say, due to space constraints, you want to move one of these in-feed buffers to a different position. What that means with classical robot programming is, well, you have this analog way of programming, teaching one motion after the other. All of that is gone. You need to restart again, reteach all of these positions. With online collision-free motion planning, instead, you adapt your model, you shift the position of the in-feed station in your model, and the motion planner takes care of the rest. It will compute new motions, it will validate those motions for your setup, and it will make sure that they're optimal for your given setup. To summarize this, the combination of the SIMATIC Robot Library and automatic collision-free motion planning is a tool to reduce the complexity of programming robots in quite complex scenarios like the one that you've seen here above. This is achieved by an easy-to-use tool that abstracts away from the low-level motion programming to a higher-level task-level programming of robot motions that also later on the fly optimizes your motions for your particular system. You can use this with all the robots that are supported by the SIMATIC Robot Library, which is an extensive backbone for our application. And this gives you also the opportunity to reduce the project costs and also the manufacturing costs of your solution. All of this comes with the added benefit of reduced training for your staff, even when using different kinds of robots. To summarize, the SIMATIC Robot Library combined with automatic, collision-free online motion planning is your shortcut to robotics.